In this video, we are going to talk about the combined gas law. So the notes themselves are very short, but the work will not be. So the requirements for the combined gas law. Well, let's review what is it. Well, the combined gas law is basically a math formula that we use to predict how a gas molecule or how a gas is going to behave in terms of pressure, temperature, and volume. All right, so it's one of our bigger math formulas, but it's not super hard. The requirements are pretty simple. The amount of gas has to be constant, and the reason for that is if you change the amount of gas by putting more gas molecules into the system, then you'll mess everything else up and you won't be able to use this simple formula. There is a way of accounting for the change in gas, but that is more of an honors and AP topic, and so we're not going to mention that. We're just going to keep the amount of gas constant. And then 2, the temperature must be in Kelvin, and the reason is really simple. If you look at the formula itself, the temperature is in the denominator, and if 0 Kelvin is a temperature that basically is impossible or is unachievable, some people would say. And so if you use Celsius, we can have 0 Celsius all the time. Actually, STP is 0 Celsius, and therefore, if we were at standard pressure in Celsius, right, or standard temperature, you'd have a 0 in the denominator, and that wouldn't work out mathematically. So we are going to always keep this in Kelvin for that reason. All right, and then the last part. If any one of these variables is constant, P, V, or T, doesn't make a difference, remove it from the equation and pretend like it was never there to begin with. So in other words, if the temperature were constant in this equation, then the formula would just become P1V1 equals P2V2. If the volume was constant, then it would just be P over T equals P over T, and you get the idea. We will often use the temperature scale conversion on these types of questions because they will very often give you the temperature in Celsius and expect you to convert them to Kelvin. You have to know that part. And then the last bit is the pressure. It doesn't matter which pressure you use as long as they're the same. The same goes for volume. So in other words, I don't care if you're using centiliters, milliliters, or liters for volume. It doesn't make a difference. As long as V1 and V2 are the same unit, that's totally fine. The same goes for pressure. As long as P1 and P2 are in the same units, it doesn't matter which pressure number you use. Temperature is the only required one. It has to be Kelvin. And then the last bit is a vocab issue. A fixed rigid container. They like to say this a lot. So if a container's a box, if it's rigid, that means the walls won't bend or flex, changing the volume. So in a rigid container, the walls won't bend or flex in order to change the volume, right? Like if you overfill a container, like if you overfill a water bottle, maybe you've seen it. Sometimes the edges or the edges of the container will bow out, making the container a little bit bigger. Well, in a rigid container, that would never happen. And in a fixed container, it means it's not going to change its shape or size. And so it's basically like saying the same thing, but in a fixed rigid container, the walls will never bend or flex or change their size. What that means to us is that the volume is constant. So just be aware that if you see fixed rigid container, that is a very sophisticated way of telling you that the volume is not going to change. And just like I mentioned up here, if the volume's not going to change, we're going to remove it from the equation. So if you see fixed rigid container, just think of it as constant volume, because that's what it ultimately means, and therefore remove volume from the equation. So that explains the notes. I will, in a separate video, go over a bunch of practice problems, and we'll go over all the permutations for this type of equation. Basically, there's 3 variables, and so they can put the x in any one of the 3 locations, and in the practice, we're going to do exactly that. Put the x in every single possible location and give you every possible type of question you could get there. That way, there'll never be any surprises when you see one of these questions.